Welcome to the session on Single Minute Exchange of Die, SMED. SMED, or Single Minute Exchange of Die, was developed by Shigeo Shingo, a Japanese industrial engineer renowned for his contributions to the Toyota Production System, TPS, and lean manufacturing principles. Shingo worked closely with Toyota in the 1950s and 1960s, where he developed and refined SMED as a methodology to reduce changeover times in manufacturing processes. His work has had a significant impact on improving efficiency and productivity in manufacturing industries worldwide. In a manufacturing setting, it mainly applies to product changeover, equipment setup, preventive maintenance and breakdown maintenance, etc. In SMED, changeovers are made up of steps that are termed elements. There are two types of elements. Internal elements. Internal elements are the activity that must be completed while the equipment is stopped. And external elements. External elements are those activity that can be completed while the equipment is running. The SMED process focuses on making as many elements as possible external and simplifying and streamlining all elements. The SMED system has three major phases. 1. Separate. Separate refers to the process of identifying and distinguishing between internal setup tasks and external setup tasks. 2. Convert. Convert in SMED involves transforming as many internal setup tasks as possible into external setup tasks. And 3. Streamline. Streamline refers to the overall process of optimizing setup procedures to make them as efficient as possible. Now let's understand with step-by-step roadmap for a simple and practical SMED implementation. In SMED, the first step is to identify pilot area and set up a team. The second step is to measure changeover time and identify elements. The third step is to separate external elements. The fourth step is to convert internal elements to external. The fifth step is to streamlining elements. And the sixth and final step is to accelerate progress and standardize. Now let's understand them one by one. For a good changeover, it is necessary to give a good team together. Team should be between 5 to 7 people, including an operator or a foreman doing the changeovers, and an engineer or technician familiar with the machines and processes. Start by identifying the changeovers that have the most significant impact on production efficiency or cause the most downtime. These are the changeovers that will provide the most significant return on investment when streamlined. Once the target equipment has been selected, record a baseline time for the changeover. Changeover time should be measured as the time between production of the last good part at full speed and production of the first good part at full speed. In the second step, the different steps of the process must be identified for the entire changeover process, and its time must be measured. Taking video helps, as this allows us to watch the steps again. The time of the video also allows easy measuring of durations. Next, we check which of these changeover steps have to be done while the machine is stopped and which can be done while the machine is still running. These are usually called external steps with a running machine and internal steps with a stopped machine. Below is a graphic representation where green indicates external and gold indicates internal steps. In the next step, elements of the changeover process that can be performed with little or no change while the equipment is running are identified and moved external to the changeover, that is, performed before or after the changeover. It is not unusual for changeover times to be cut nearly in half with this step alone. For each element, the team should ask the question: Can this element, as currently performed or with minimal change, be completed while the equipment is running? If the answer is yes, categorize the element as external and move it before or after the changeover as appropriate. In fourth step, for each internal element, the team should ask the following question. If there was a way to make this element external, what would it be? How could we do it? Below is a visual representation of this process. You can see that the time of the stop is already reduced. Hence, you can get more parts out of your process since the stop is shorter. After moving the internal steps to external, we now shorten the internal steps. Check if the procedure can be simplified. Check if there are better tools available. Eventually, the new setup may look like the image below, where both the time of the stop and the overall changeover time may be reduced. Next, we do the same for the external elements. Check if we can shorten the external elements. This will not reduce the stoppage of the process, but it will reduce the overall time of the changeover and hence the workload for your workers doing the changeover. The last step is the most difficult one and the most frequently forgotten one. It is not enough to do a changeover quickly once. You have to do it quickly every time. So you need to fix the new standard, document it, train all relevant workers in the new standard, and do a process confirmation. Any standard not maintained that way will be soon lost. Following points shall be followed. 1. Document and control new work procedures for changeover task. 2. Be as precise as possible with cycle time and each step. 3. Draw a spaghetti diagram for this work procedure. 4. Give training to all the stakeholders with respect to this procedure. 5. Displace one-point lesson, OPL, or single-point lesson, SPL, near the machine area. You could check every now and then if the standard is still followed. By following this step-by-step roadmap, the companies can effectively implement SMED techniques to reduce changeover times, increase equipment utilization, and improve overall production efficiency. Thank you for listening.